Hello everyone. We just finished chapter 17 and we will start the last chapter, chapter 18, which is carbonyl compounds. Same as before, I will give you some background information about this chapter before we go back to the lecture notes, okay? So for the lecture notes, I already sent to you yesterday, okay? So if it's with you, then you can take it out as well. Let us have some background information first. Chapter 18, Carbonyl compounds. Okay, now in chemistry, carbonyl compounds refers to two functional groups. One is aldehyde, or you can call it alkenyl, okay? And the functional group is C double bond OH, okay? It's always at the end at the ending of an organic compound, so you don't have to use number to indicate its position. Think about if it's embedded in the middle, then it's a ketone already, right? The other one is a ketone, okay? And it's C double bond O, okay? With the left and right hand side bonded with the alkyl group, okay? Now, when we learned a homologous series organic compound, we will talk about the preparation first. Preparation. That means how do we get this in the laboratory? Now for aldehyde, I bet you already know it. It's from the oxidation of primary alcohol, right? Because we know that when alcohol is oxidized, primary alcohol is oxidized, it will go to aldehyde, okay? Then if you don't stop the oxidation, it will go to carboxylic acid. So if you want to get this one, as I told you, we will use distillation. For distillation, you have to know how to draw the experiment setup. I will demonstrate how to draw this to you later, okay? So for example, if you have CH3, CH2, OH, and if you oxidize it with distillation, if you use heating under reflux, then you will get carboxylic acid, right? But if you start the setup with distillation, you can isolate the aldehyde out, okay? So now it will become, this is ethanol, right? If you use oxidation, it will become, if you use distillation, it will become aldehyde, okay? Then if you remember how we balance the reaction, for oxidation we use bracket O. It represents the number of oxygen atoms, okay? So that when you take a look on this equation, here there are 2 hydrogen, right? And then altogether 3, right? But here is just 1. So we will use water to balance the number of hydrogen, but when you add a water on the right hand side, you will find that there are 1 more oxygen here, 1 oxygen, 2 oxygen, and here is just 1 oxygen, so we use O to balance it. Okay, that's the preparation of aldehyde from the all in all is from oxidation of primary alcohol together with distillation. Okay, then how can we draw a distillation setup? Okay, it's easy because we already learned it in Form 1 IS. Now for distillation, a simple distillation, not fractional distillation, we don't need a vertical condenser. We don't need a vertical condenser because it's called fractional distillation. So when you draw it, is my drawing sucks, so you better refer to your textbook. But in the exam, we will look at students things like that. Water in, water out, and here is a thermometer. Now remember to close this with a thermometer because it's different from heating under reflux. For heating under reflux, you have a very long vertical condenser. So the organic molecules, when they vaporize, when they touch the wall of the condenser, they will condense and drop back to the reaction mixture. But if you don't close this setup, all the organic molecules will vaporize and go away upon heating. So okay, so this is water inner, Now remember, water in is at the bottom. This is water out. So as to make sure the whole condenser is filled with cold water to maximize the condensation efficiency. And here, for example, this one, we have ethanol, and then we have acidified dichromate solution, and then you can add some anti-pumping granules. Okay, and then here is heat. Don't miss heat. Okay, if you don't add heat, 0. Because it's just a decoration. Okay, then the things you get will be ethanol. Okay, are you clear? Now the bulb of the thermometer has to be facing to the condenser, okay, so that you will know the boiling point of ethanol when it is distilled out. Okay, so are you okay? And then we go to preparation of ketone. Preparation of ketone is also we use oxidation of alcohol, but instead of primary alcohol, we will oxidize secondary alcohol. Okay, so preparation of ketone. So we use oxidation of secondary alcohol. Now for this one, if you want to, you can use heating and reflux because the ketone is resistant to oxidation. Remember, that means when a ketone is formed, it can no longer be oxidized further to any other product. So you can use heating and reflux to make sure the reaction is complete. But heating and reflux is basically a vertical condenser connected with the pear-shaped flask. So I'm not going to draw it up. I bet you have already drawn the setup for a lot of time. Okay, so basically is you have a secondary alcohol. By means of a secondary alcohol, the carbon that is bonded with O contains one hydrogen atom only. So this is a secondary alcohol, right? Now, upon oxidation, what will be happening is this group will remain, and then you just have to draw a double bond here and cross out these two parts. Then that will be a ketone, okay? So you will get RCl-O, ketone, okay? Now let me give you a concrete example. For example, if you have CH3, CH2, CH3, HOH, right? What's the name of this one? Do you remember? What's the name of this one? Let's do some practice. We choose the longest chain, and the functional group is carbon 2. Carbon 2. So this is butane 2O. Okay. So when it is undergoing oxidation, it will get this one. Okay, this is butane long. You don't have to say butane 2 long because you don't have butane 1 long. Butane 1 long is an aldehyde, right? If the old thing about if it is a position 1, it is an aldehyde. So butane long. Okay, now then you balanced first. Let's take a look. You balance the hydrogen with the water. So you have 1 hydrogen, 2 hydrogen, with the other part remain the same. So 2 more hydrogen on the left hand side. You put a water here. But when you put a water here, you have 1 O, 2 O. But here you only have 1 O. So we add a O here. Okay? So that is the balanced chemical equation representing the oxidation of a secondary alcohol to produce ketone butane long. Okay? Do you have any question? If not, then I want to do some revision review on how to draw the display formula and the skeletal formula of some compound. Okay, classwork. Okay. So for example, propanol lah, aldehyde, right? 3 carbon, 1, 2, 3. So okay, for skeletal formula 1, 2, 3. Then O. Do not draw any H for skeletal formula because all the H atoms are contracted. 1 carbon, 2 carbon, 3 carbon. Okay? Any questions? No, then we try pentane 2 long 啦。嗱，you may wonder why do I need a 2 here, but butane long doesn't 呢？ Because you don't have butane 3 long, you don't have butane 1 long. Think about it. Butane 2 long is equal to butane 3 long, and butane 1 long is an aldehyde. So the number is redundant. But this one is not, because pentane, right? Pentane 2 long is this one, right? Now, remember in the exam, draw the hydrogen hour. Right now, I don't want to draw it because it's pretty confusing now. And pentane 3 long means the oxygen is here, okay, at number 3. If you have to draw the skeletal formula, 1, 2, 3, 4, 5, okay? And this one, 1, 2, 3, 4, 5, okay? Each corner represent 1 carbon, 1, 2, 3, 4, 5. Please get used to use skeletal formula as well. And then at the last one, after this one, I will pause the video and I will make another one because, as I said, it cannot be longer than 15 minutes, okay? So methanol, 1 carbon, right? So 1 carbon, aldehyde, and this is H, methanol. So if skeletal formula, just like that, do not draw anything, right? Because each corner represents 1 carbon. So here is 1 carbon only. There is the carbon, okay? Okay, let's just stop here first.